my exponent rules tell me that negative exponents are happy. No, they're not. But I also know that my exponent rules, when I have the same base with different exponents and I'm multiplying, what do I do to the exponents? I add them. So in this case here, could I move them first? Could I add them first? Or does it matter? It really doesn't matter. Now, what I would do is I would move them first, because a lot of times you know that you're going to have to add them. You'll probably accidentally add them and just not move them. So be careful when you start seeing stuff like that. But now, the big question is, what do I do with the 4 and the 2? We leave them and we multiply them and you get 8. So in the denominator then, we all know what 1/2 plus 1/4 is, right? 3/4, good. Now, can I leave a fraction in a denominator? No. So, how many more fourths would it need? Go top and bottom with a fourth. And you get that. Pretty basic. Not too crazy. Go to number 8. So this is asking you, what is the cube root of negative 1,000? Take a guess what the cube root of negative 1,000 is. Is it 10 or negative 10? Which one? Negative 10. So I know that this becomes the negative 10, so it's negative 8 times negative 10. Then I have a cube root. What do I do with the x squared? Nothing. So does it stay or does it go? It stays. Cube root of y cubed. Y, so how many come out? Is there anything left? Okay. Our son, Moose, he's got his spelling words, and not spelling words, but it's like sight words that they're doing in kindergarten and whatnot. One of the things that they have baseball words. When you master baseball words, you go to soccer words, and you go to basketball words, you go to all that stuff. So right now we're on soccer words, I think. And one of his words, he was reading it, and he's sounding out his letters, and it said, and he goes, Daddy, what does this spell? W-H-A-T. I said, what? I just asked you a question. He goes, what is this? What does W-H-A-T spell? What? Daddy, stop it! I was trying so hard not to laugh. He goes, oh, it spells what? I go, what? Parenting is awesome. So how many times does 3 go into 7? So 2 come out, and 1 stays in. What? Hey. And then the fun stuff happened. I did. It's a cube here. Oh, 8. Thank you. Sorry. Then the fun stuff happened. Ten. Ladies and gentlemen. And then all the fun stuff started happening. Nope. That's power to power. You're thinking of So now here's what happens, guys. When you start getting really, really, really nasty looking things like this, remember, I've always suggested that you try to make everything positive first, and then if you have any power to power stuff, you take care of that as well. So I know that in my denominator, I've got power to power rules, which means when you have power to power, what do you do to that? Multiply. Okay, so I know I have that. I also know that I have a negative exponent in my denominator that will have to go up. I've got two negative exponents in my numerator that have to go down. So I think in this problem, the easiest thing to do first is to distribute my 3/4 exponent. So 3/4 times negative 5/3 would be negative 5 over 4. Because when you multiply, three drop out, you get negative 15 over 12. Divided by 3, you get negative 5 over 4. Okay. So I know I have a x negative 5/4. Then I do the same idea with the 1/4 times 3/4 gives me 3/16. I'm going to move those two down, x to the 4th, and then y to the 3/2. This y cubed stays down here. This x goes up, and I think we've moved everything except for that x to the 5/4. Now, before I move that, what's negative 5/4 plus a 4? Negative 1, right. So I get negative 4/4 here. So this one goes away, and this becomes a negative 1. So when I bring that up, I got that. You okay with that so far? I did negative 5/4 plus a 4th give me negative 4/4, which is negative 1. Bring it up. So numerator is easy. Denominator, we have to add 3/16, 3/2, and 3. Well, they need a common denominator of 16. It's not terrible. So it's 3/16. Multiply that by 8, we get 24/16. Multiply that one by 16, you get 48. So what's that? 72/75/16. Well, that's just pretty. So think about going by 16ths. 16, 32. If I double 32, what do I get? 64. If I do another 16, that gives me 64 and yeah, it'd be 80. So how many more 16ths do I need? 5. So you have 80/16, which is y to the 5th, I believe. So our final answer is x squared. Y to the 5/16 over y to the 5th. A lot of review jokes. Or not examinate mañana. I don't know. I haven't made a decision. Take a second and try number 11, and we'll check it in a second. 11. Take a minute, give that one a shot, we'll see how we do. So we get B 7/4, B 4/3, a to the half, a to the fourth. Should I even try to attempt to play war with the a to the half and a to the fourth? No. Right, exactly. Remember that trick, guys. If you've got a fractional exponent in the numerator and a whole number in the denominator, 9 times out of 10, you're not going to be able to do anything with it. Right? The only thing I would suggest is if that was 3 halves and the denominator was 4, what could you do? You take out 1. Okay, so just watch those if you have mixed numbers. So now you just have to add 7/4 and 4/3. That gives me a common denominator of 12, I believe. So I get 21 and 16, so it's b to the 35th 12. 37. I was making sure you were paying attention. Good work. I use that line a lot. I think I'm putting it out. You get that? I did the denominator between 4 and 3 again as well. So the fraction on the right needs to be multiplied by 3. The fraction on the left needs to be multiplied so I guess if I multiply by 3/3, 4/3, 3 times 7 is 21. Inverses. Inverses are easy. Number. But I want to look at number 21. What does that mean? F of x? Yeah. Not fava beans. Sorry. Berries. So berries. A lot of stuff. Yes. Yes. I was just about to say that. Now, the other thing I want you to know, this stands for what we've seen before as f of x. A lot of times they write it as f of x. That way it's less parentheses, I think, but not really. The other one is f plus g of x. It just means f of x plus g of x. That's all it means. Because you think about it, this is multiplying, so you can distribute the x back in. It's just, sometimes it works. So if I do f of x, it means write down the f equation, surround it with the f equation. One thing that I do know that you will forget, not to say that you ever forget anything, is a lot of times on these types of composite style questions, if there's a +1, +2, minus something or another at the end, after you do everything else, you forget to put that tail on it. It's just a simple overlook. Just be careful. Distribute and combine like terms. You get that. I'm sorry, what's that? H of g of h times g. So 22, it says h. That means multiply them together. When you see the closed dot, that means you're multiplying them together. If you see the open dot, that means you're putting them in for one another. Okay? Yes? Now if I flip over, what are you going to do? Square it and don't kill a puppy. Very good. When you square x minus 3 quantity squared, you should get x squared minus 6x plus 9. Subtract 4x, add 12. Enough. What times what's 21? You add together to get negative 10. Good. Negative 7, negative 3. Possible zeros at 7 and 3, which means, what do you always have to do with these? Check them. You gotta double check these, make sure they work, guys. Sometimes you get an extraneous solution. What is 7 minus 3? 4. What is 4 times 7? 28 minus 12 is? Square root is? That works. What's 3 minus 3? What's 4 times 3? 12 minus 12. Square root of 0. Does 0 equal 0? Is it okay to have 0 equaling 0? Absolutely. The rest of the stuff, I mean, we've done ample, multiple, lots of equations and solves and stuff and things and whatevers. The answer sheet? Yeah, I'll put it on my. Shut up, Sawyer. How about this, Sawyer? In case I forget because I'm old, would you like to take a picture of it right now? No. No, because that's Carter's job. I'm pretty sure Carter emails me, are you going to put these up? More than you do. And he doesn't say a word about it. Because he's respectful. Shut up, Sawyer. Or not, Carter. It's just easier to yell at you. So, yeah, if you don't feel like using the internet because it's difficult, I know, it's really tough. You can take a picture of it. What time's your flight out? You guys go tonight, right? Oh, okay. So you will be here tomorrow. Okay, I thought you were leaving today to go tomorrow. Super exciting.
I feel like
All right. Stupid schoolwork.